Hey kids, today we're going to look at section 7, which deals with rational expressions again.
Yeah, solving equations in one variable where we're going to see rational equations. So in the previous section we talked about rational functions, or functions with a fraction in it, and we have this similar little thing over here, right here, f of x over g of x, but now we're saying it can equal 0. And now we have an equation instead of just having a function.
Right, so we can actually solve these out and go, what values of x's really will give us a 0 there?
Right.
And for the rational part of that, I don't know, what do you think? How do you want to solve these?
Well, typically what we do is we try to get rid of the fractions.
That's so great. Got it, girl.
Yeah.
I like getting rid of fractions.
Yeah,
Man, it makes life easier.
But the way we do that ends up a lot of times giving, well, not a lot, but some of the time gives us extraneous solutions. So this fancy word right here, extraneous.
Extraneous means extra.
Yeah, extra solutions. And so solutions that are not really solutions to what we originally had.
You're going to have to check every answer you get. You have to check every answer you get when you solve a rational expression.
Yes, because you don't know if it's really an answer or not.
And you'll know, because when you check it, you'll either get something that's undefined or you'll get something that isn't.
Yeah, and so this says up here f of x over g of x equals 0. If we look at example 1, this doesn't equal 0, but that's okay.
That's all right.
Like, we could write it as equal 0 if we wanted to.
We could.
That's what's important. So let's start off by thinking about what we would need if we want to get rid of our fractions. Basically, we're going to try to multiply by something that will get rid of what's on the bottom. So write everything as a fraction, right?
It's a good start.
What would the common denominator be of these three terms that we have?
X minus 3.
Right, because we have a 1, and an x minus 3. So what we're going to do is we're going to multiply everything in the equation by x minus 3.
That is genius. And remember, follow algebra rule number 2376.
Yeah.
Whatever you do to one side of the equation, you got to do to the other.
Right, so we have to
Very
basically
important rule.
distribute this to all three of these things. So when we do x minus 3 times x, well, let's just write that out and we'll actually distribute it here.
It's a good plan. It's a good plan.
And notice that that would be over 1 still, but we don't have to write that.
Yeah, we just cleared out the fraction with this step, which is why we're doing it.
Here, 1 times x minus 3 is on top, and then x minus 3 is on bottom. And so what happens is, because of the way we picked our common denominator, these will cancel each other out, getting rid of that fraction.
Which is what we wanted.
Yeah, that's the whole point.
That's why we're doing what we're doing.
And then we have 1 times x minus 3, which is just x minus 3. So let's go ahead and distribute on this side. That's x squared minus 3x. We have a plus 1 here from this term. And on this side of the equation, we have x minus 3.
So basically, all we've done is taken a trick that you learned in like 5th grade when you started working on fractions and finding a common denominator. We just took that same trick, but now we've added in stuff that's not quite as nice and neat as 1/2 plus 2/3.
Right.
Okay, but it's the exact same principle.
Yes. So if we have a quadratic here, the best thing to do is get everything on one side and either factor or quadratic formula.
Yeah, make a 0. Make a 0 somewhere, and you can either go left or right. It just depends on
which way's easier.
Which way's easier, but typically you want your x squared term to be positive.
Yeah, because if you are going to factor, that's going to make it easier to factor.
On most days.
Most days.
Yes.
All the days that end in y.
Yes, that
Okay.
would be a fair thing to say.
Okay, so now we want to try to factor this if we can, because that's faster than the quadratic formula.
Yes.
And
I'm thinking it does.
I am too, because what multiplies to get 4, that will add to give us -4.
2. Negative 2.
-2 and -2. Because when we multiply them together, the negatives cancel out and make a +4 here. And then if we add them together, we get the -4 right there.
Right.
So that means that we actually have two answers that are the same in this case, because x minus 2 would equal 0 and x minus 2 would equal 0. So x equals 2.
And if you refer back just a lesson or two, you would remember that this would be a multiplicity issue.
Right, and so if we were trying to, graph or something like that, then we may need that. But typically, we don't necessarily have to write that.
No,
it has
we
a
don't need
multiplicity.
to. No, but it's a bouncer.
Yeah, it is. Okay, so what we need to do is go back and check this to see if it really is a solution into our original equation. So we plug in everywhere that x was a 2. We want to know if it's actually equal. That's what we're trying to figure out. So just work this out real quick. 1 over 2 minus 3.
-1.
Right, so 2 plus a -1.
Yes.
Well, 2 plus a -1 is
1.
1. So that means that x equals 2 really is an answer.
Fabulous. So let's take another look at a different example with relatively similar.
Basically, all of these are going to
Actions.
work pretty similarly. We just want to make sure that we understand what's going on. You should be prepared to solve any sort of rational equation after you're finished watching these notes. So again, we want to look at the common denominator situation here. And so since those are both 1s, that means our common denominator would come from this middle term, which is x.
Yep.
So we're going to multiply everything by x. So if we distribute that through, we have x times x, which is x squared. It's over 1, so that won't end up mattering.
We don't write it.
Right, x times 2 on top gives us 2x, but then we're dividing by an x.
Right.
So that's really just plus 2.
Right.
And then x times 3 is 3x,
3x.
over 1.
You got it. Put everything together on one side of the equation, get a 0 on the other, and in this case it's easier to leave your x squared and 2 alone because typically you like to have x squared positive.
And that's less terms to move anyway, so x squared minus 3x plus 2, let's factor that if we
Thinking
can.
a factoring type of thing is going to happen here.
So what multiplies together to give us a positive 2 that will add to give us -3?
-1, -2.
Yes. Which means that our solutions are +1 and +2. But we're not done yet. We need to go back and plug each of these in to see if they're really answers. So
Because you just never know. And probably if you eyeball them from here, you're going, hey, I think they're going to work. But you don't know. You got to check. And this is the old school checking, like in Algebra 1 when your teacher told you to check stuff to see if it worked and you said you did and you erased to make it work. It's that same deal. If you
Yeah.
have to erase to make it work.
yeah, if you realize because you did something wrong that you made a mistake,
Yeah,
then. All right, so I have 1 plus 2 over 1, which is 2, equals 3.
that's good.
That one's good. And then 2 plus 2 over 1. No, just kidding. That's not how that works.
I feel like that should
That
be
should be
2
2
plus
on the
2
bottom.
over 2.
Yeah,
actually.
yeah, my bad. I forgot what I was plugging in. Equals 3. Well, 2 over 2 is 1. 2 plus
Look at that.
1 is 3. So that one also works. So
Fabulous.
both of these are answers. Just because you get 2 answers doesn't mean that one of them will always end up not being 1.
They
Like,
could
it just
both work or
depends.
both not work or
Yeah.
just one.
Yeah,
But you have to check.
yeah, you have to check. Now let's get a little bit more complicated with these common denominators, shall we?
Shall we indeed?
We've got 3 actual fractions here. And notice in this last one we've got x squared minus 6x plus 8. I would recommend we factor that and see what that is because that's the most helpful thing to do when you start common
That's a
denominators.
recommendation worth listening to because how are you going to know what to look for if you don't have things broken down into their smallest bits and
Right.
pieces?
It's kind of like whenever you do like 1 over 8 plus
1 over 6?
Yeah.
You could choose 48.
Yeah, because 8 times 6 is 48. But if you realize that, hey, this breaks down into 2 and 4, and this breaks down into 2 and 3, and you realize, hey, they have a 2 in common, you'd realize, oh, 24 works.
Right.
So that's what we're doing by factoring this over here.
We could multiply everything by x squared minus 6x plus 8, but there's really no need to multiply that.
Because a lot of times it'll work out like this because it's helpful. What multiplies to get 8 that adds to get -6, -2, and -4. Which, look, that's what our denominators on the left side are. So your common denominators have to have every single representation here. So we have to have an x minus 2. We have to have an x minus 4. And in this denominator, we already have both,
got both of those.
So we just need our common denominator to be x minus 2, x minus 4.
That is correct. That's all there is to it. So multiply the whole thing. And again, like we said on the very first slide, you've got to multiply every single thing on both sides by x minus 2, x minus 4. That's a simple rule of algebra that you picked up when you took Algebra 1.
So the way we work this out now when we distribute, if we distribute to that first term, we have 3x on top what's going to cancel? Our x minus 2's will cancel, so that we'll just end up multiplying by x minus 4.
Right, and that's why we're doing that, because we want to get that denominator to cancel out and go away.
If it doesn't, you didn't pick the right
That is
common
correct.
denominator. Now, if we distribute here to this 5, the x minus 4's will cancel out, so we need to do 5 times x minus 2.
Yes.
And then on the right side, this one's the best, because if I
It's all
distribute
gone.
this, I had all of this, so it all cancels and it equals
Just
10.
like the Mega Millions I won last week, all gone.
Oh, really?
Yeah.
You didn't share.
No, it's all gone.
That's a little awkward.
Sorry.
I thought we were friends.
We are,
Let's
except for my
distribute.
Mega Millions.
Let's distribute the wealth.
That's a good
We're
one. That's a good one.
distributing.
Yeah.
Okay, so 3x times negative 4, negative 12x. Distribute the 5 here.
And it's going to be 10x minus 10. 5x minus 10. Excuse me.
That was a close
Mega
one.
Millions on the brain.
So we've got like terms over here on this side, and let's go ahead and add 10, shall we?
We shall indeed, yes. Hey, looky there. One of the 10s goes away. I like
No,
it.
he didn't. No, it didn't. I messed up. This is
Ah.
minus.
Ah!
That was a silly mistake. There we go.
Well, what I meant to say was, hey, looky there. The 10s go together.
Yeah, exactly. So 3x squared minus a 7x.
Yes, it's 1 7x. That is correct. A
Minus
singular.
20.
Yes, very good. Fabulous.
0.
Yes.
Now, slide and divide or quadratic formula?
I'm not saying that slide and divide is going to be beneficial
box.
here. I'm feeling
Let's
quadratic
try
formula.
the quadratic formula then. If it doesn't look obvious that you can go ahead and factor something, you might as well use the quadratic formula.
Because it will factor. If it is something that will factor, your
It'll work
quadratic
out.
formula will come out nice and pretty.
Yeah.
So,
I don't
just
think they'll go.
opposite of b,
Opposite.
plus or minus the square root of b squared minus 4ac, all over 2a's.
Feel free to sing the song as you go.
Dude, I always do.
No, not
I,
you,
I
them.
start off with row, row, row your boat and end up with pop goes the weasel. That's how mine goes. Yeah, it's really weird. Don't ask me how it happens, but it does.
49 plus 240.
Oh, it's got to load.
289.
Not that I doubt you, but I'm just going to double check you.
Okay. Over 6.
Keep teaching. I'll punch in.
The square root of 289 is 17. Are you actually checking? 'Cause
Yes, I am, but it was loading, so now you got to wait.
Okay.
So it's coming.
So
Here we
the
go.
square root of 289 is 17.
It's like going through a reboot here. I don't get it.
So we have to do 7 plus 17 over 6 and 7 minus 17 over 6.
289.
Thanks. Is the square root of 289 really 17?
Let me just double check that as well. Son of a gun, you're a genius.
7 plus 17 is
Wow!
24, divided by 6 is 4. 7 minus 17 is negative 10/6, which simplifies to be negative 5/3.
Look at that.
Now we need to go back and check. So this is going to get fun. 3, let's do 4 first, right? 3 times 4.
Oh, yeah, definitely 4 first.
Over 4
yes, I
minus
agree.
2 plus 5 over 4 minus 4 equals, oh no, 4 minus 4.
Oh,
That's terrible.
Shoot.
This right here is our problem. And typically I feel like a lot of times that's where our extraneous solutions end up coming from, because if I plug in 4 here, guess what? I get a 0 on the bottom, and that's not allowed. So that means that 4 is not really a solution. It's an extraneous solution. So let's try negative 5/3 and see if that one works out.
I guess we'll try it and see. I'm really bummed out about that 4 because it was going to be easier to do the math. No lies.
Well, either way, we were going to have to do both. I would say it would be good to use our calculator maybe on this one, don't you think?
Perhaps the old TI something will come in handy. 3 times negative 5/3. Hey, that's a 5 on the top. On the left.
Oh, yeah, you're right. That cancels. Good call.
And negative 5/3 minus 2. Let me just get fraction. Common denominator is going to be 11. It's going to be 5/11 on that first one. Negative 11/3.
Is it negative 5?
It actually
over
is going to be
negative
5/11 because the negatives are going to cancel out.
5 over negative 11
No,
thirds.
5/11.
5 over 11
Yeah,
thirds
5/11. So 5 divided by 11/3
is really
is really
15 over 11.
15/11.
Okay, and then this next part, negative 5/3, we need a 3 on bottom, which makes this a 12. It's negative 17/3. We
So
flip up
5
and
divided by
multiply,
17/3 is
and it's negative. So that's 15 over 17.
17ths.
Oh boy, this is
Yummers.
25
So that's going to
over
be
9.
10 divided by negative 5/3. Let's see, 5/3 squared. 5/3
Yeah,
squared.
25 over 9 plus 18.
3. Oh shoot. Let me just get this situation going here. 10 over and then negative
Why do you have a negative?
5/3
Oh, you're actually plugging it in.
squared. Plugging it in.
Do you want to say hi to the children?
Hi, kids.
Minus
That's Coach
6
Allstat
times
saying hi.
negative 5/3.
Close your parentheses.
Close parentheses plus 8. And
Change
that,
it to a fraction. Math
Yep,
learner.
I'm on it. 90 over 187.
Wow.
Yeah.
So we're trying to figure out if this is really equal. So 15
it's
over
got- I think it's
11
got a
minus
shot.
15 over 17.
15 divided by 11 minus
Minus
15 divided by 17. Math.
enter.
Enter.
Hey,
90 over
hey.
187.
Awesome. So
Open the
negative
fridge.
5/3 was indeed
It's a
an
worker.
answer. So this one was a little bit tough, that fraction. Remember, you can use your calculator. It is helpful to make sure you understand the rules of common denominators. And
Yeah,
all
common
that stuff.
denominators are important.
If you like a challenge, then, work it out by hand. But remember, you can use your calculator there to check it. Don't just blindly assume that it is really a zero. I mean, not a zero, a solution just because the other one wasn't.
The other thing that you could do that's kind of sort of cheating a little bit, but while you're learning it's good, is you can graph the left-hand side of the equation and the right-hand side of the equation, and the x value they intercept that is a solution.
That's true. But we will have to do a lot of this algebraically by hand.
That is correct.
So don't only do it
don't,
that way.
Don't only do
But
it
if it
that way.
asks you to solve it graphically, yeah, that's exactly what we
That's
would
what you do.
Okay.
All right, good talk. Last example.
Uno mas.
Yes?
Yes.
I'll take 2, please.
Okay, so like last time, we want to start off by factoring anything that's factorable on the bottom. So x squared plus 3x, we can take an x out of both of those.
Righto. So it does factor, it's just not quite as...
Not the same way that
not
we've
in the
been
same way.
factoring.
Right, but, this is a thing that you still have to be able to do.
Yeah.
You got to be able to recognize all the different types of factoring that could occur.
Right. So if we look at our denominators, we've got x plus 3, and x times x plus 3. So that means we need to multiply by x times x plus 3.
Right.
Because every denominator has to be represented here.
Yes, that's a great word. Represented is a great word to use in this situation.
So if we distribute to this first term, there is an x on bottom, there's an x over here, those will cancel. So we really just need to do x minus 5 times x plus 3.
Yep. And this could potentially get nasty if things do or don't go away as you're reducing.
Right, it could. So now distribute to the middle term here, the x plus 3's cancel out, so 5 times x is 5x.
Right.
And then
Plus,
both of these
they're
cancel,
gone.
so we get
Dunskies.
15 equals 0. So we have to FOIL this first part here before we can add like terms.
can you foil this in your head on a quick?
I can,
it's a
because
good-
the middle term you add together the two numbers and put an x with it.
Yeah, and it's a good habit to have to be able to do that.
Right, and since we did a whole bunch of this just a couple sections ago with imaginary numbers, whoopsie, right in the wrong
I feel
thing
like
there.
you wrote 15 twice there, Mrs. Stevenson.
Right, but it's 5x
Right.
and then plus 15.
Right. That's what I said.
Oh, Okay,
Yes.
so this minus 15 and the plus 15 will go away.
Are you sure this time? Because
sure this
earlier you
time.
tried to do that and it wasn't quite ready for that.
X squared plus 3x
Equals 0. Mm-hmm.
So to solve this, we would factor out an x. Hey, this is starting to seem a little familiar to me. X equals 0.
I smell
X
something
equals
fishy.
negative 3. If we go back to plug these in, let's see. 0 minus 5 over 0. Oh,
Ugh.
0 is not going to work.
Undefined.
So no x equals 0. How about the negative 3?
Let's do it.
Negative 3 minus 5 over negative 3.
Keep going.
Plus 5 over negative 3 plus 3. Oh, that one gives us undefined on the bottom.
Shucks
So
and gee whiz.
neither of them are actually solutions. They're both extraneous, which means that this has
No solution.
solution.
Hey, and guess what? You're going to run into these sometimes.
Every now and then they do come up.
And we wouldn't have caught that if we would have stopped with x equals 0 and x equals negative 3.
Right. Don't forget to put the code word that appeared somewhere in this video
Submit it through your Edmodo assignment.
so that you get credit for watching the video.
Sounds
so
great.
Somewhere in this video there was a code word. Somewhere.
I don't know where though, because I don't see anything on the screen except
we didn't
math.
say anything.
So,
Somewhere.
do you think they'll get it?
I don't know. We'll
All
find
right.
out.
We will.
We were trying to be clever.